Hi, everyone, and welcome to today's webinar, Getting to the Low Latency, High Availability Goodness of Distributed Postgres in 3 minutes or less, sponsored by pgEdge. I'm Jacob Lukowitz, Multimedia Editor at SD Times. Now, before we get started, I have a quick couple of housekeeping announcements. First, this webinar will be recorded and available on demand through the sdtimes.com website around 24 hours after the event. Secondly, if at any time you have questions about or during the presentation, you can submit them using the chat on the right side. Now for today's webinar topic, we'll dive into distributed PostgreSQL and explore how it can empower you to deploy globally distributed edge applications that are always on, always available, and always fast. You'll also see how easy it is to get up and running with a distributed Postgres cluster using pgEdge's new Cloud Developer Edition. Our speakers today are Philip Merrick, co-founder and CEO at pgEdge, and Curtis Meisey, Vice President of Product at pgEdge. It's great to have you both here, and to get things started, I'll throw it over to you, Philip.
Thank you so much, Jacob, and thank you everyone for joining us. So we're very excited to be here talking about not just distributed Postgres, but how using pgEdge Cloud Developer Edition, you can literally get up and going with a cluster of distributed Postgres databases, experience all these benefits that we're going to be talking about in 3 minutes or less, and we're not making that up. So no pressure, Curtis, they might be timing you. If we think about today's applications, they need to be always on, always available, and they need to be always fast. And if you have global users or even users that are spread across the continent of North America, you're going to be running into this problem of latency. So your users are far away from the data center or the cloud region where your application stack and your database are located. It takes time because of the speed of light to actually get responses back. The database is the slowest part of that chain. So this is a real problem for a lot of applications. So application users can and are be globally distributed. Applications mostly are not. And when you talk to CTOs, heads of engineering, it's like, well, why have you not been able to move from a single region in the cloud to multiple regions? The answer almost always is because it's really hard to do this at the database layer. It's hard to globally distribute databases. And so that's what we're here to talk about. And that's what we offer with our pgEdge distributed Postgres. So these problems of latency and being in a single cloud region cause real business pain in the form of poor customer experiences and lost revenue. So that high latency causing slow page load times. Think about a user in Europe or Asia Pacific versus somebody on the US East Coast who happens to be close to where most people put their application stacks, the East Coast regions of the cloud providers. Think about those users who are a little bit further away and what page load times are like for them, what the user experience is like for them. And then the flip side of latency is high availability. So if you're in a single cloud region, what happens when that goes down? And we know that the cloud providers do have region-wide outages on some sort of regular basis. Amazon went down for 6 hours in the US East 1 region last year in the spring. Google's West European, main West European region was down for some customers for several days. Then you've also got the problem of what about your regular maintenance activities like upgrades? How can you do those without having to take scheduled downtime, which in a lot of applications is no longer acceptable. It's not the 1990s anymore. So these are very specific problems and pains that distributed Postgres addresses, and we're not making this stuff up. There's been a lot of research by companies like Google and Amazon and others that show that if it takes more than just a few seconds for a website to load, you've lost that customer if it's an e-commerce application. If it's a SaaS application, then you've just really taken a hit in the customer experience, customer satisfaction. And the Aberdeen group says that slow page load time, a 1 second delay can lead to a 16% decrease in customer satisfaction. Very precise numbers there from that study, but you get the point. And then downtime, well, we know how downtime affects our applications. Downtime at the cloud provider means our application is down, and we're having to talk to our customers, be they internal or external, and explain, no, really, our provider's down. It's like, well, are they down globally or just in one region? So going multi-region addresses both the latency problem and the high availability problem. And those are the benefits that we're unlocking with pgEdge Cloud. Now, let's talk about Postgres for a minute. I would imagine that many of the folks joining us today are Postgres fans and Postgres users, but we're not going to assume that. But what's been really neat to see, kind of as a slow burn over the last couple of decades, and several of us here at pgEdge, a lot of us actually have been involved with Postgres for several decades. This is something we've seen gradually, but inevitably. Postgres is becoming dominant, and it's now the most popular database among developers, according to things like the Stack Overflow developer survey. But until pgEdge came along, there was no open and supported distributed Postgres. And so we're very happy to be filling this need in the Postgres ecosystem. And we do it with our pgEdge fully distributed Postgres. We say it's optimized for the network edge, but also works great in multi-region deployments, as we've been talking about. Multi-cloud deployments. What if you have an application that needs to have data spanning multiple clouds? What if you need to replicate between those clouds? pgEdge distributed Postgres can solve that as well as hybrid cloud deployments. And an exciting application of distributed Postgres is doing AI inference at the edge. And we've got a number of customers that are doing exactly that. I did mention that we're 100% open. What we mean by that is our source code is available. Without getting into the ins and outs of open source licensing, our open source is available on GitHub, and customers are free to access that and do with it as they please. We are also fully Postgres based. So you'll see some in the market saying, well, we're Postgres compatible. Well, you need to dig in and understand exactly what that means. But with pgEdge, we're just Postgres. And our distributed capability comes in the form of an extension that uses the standard Postgres extension mechanism, which is awesome, and it's part of the reason why Postgres is so popular. So I think we've talked about how pgEdge can deliver on low latency and ultra high availability, and can give you disaster recovery and failover capabilities, not quite for free, because there is no such thing as a free lunch in the universe, but very conveniently and as part of the architecture. Added to that, given our name, pgEdge, we are also edge friendly. And what we mean by that is we integrate great with edge platforms like Cloudflare Workers. And we work great with Jamstack applications and also other edge platforms. So we're here to announce pgEdge Cloud Developer Edition, which is now in preview. And we encourage you to just go try it out and see if we live up to our word of being able to deploy in 3 minutes or less. Some of the key features of pgEdge Cloud Developer Edition, it is fully distributed Postgres, reads and writes at each of the database nodes, and it is serverless. You don't have to mess with any infrastructure. You can just get going, create your databases, and you're off to the races. So very fast to get started with. We're providing pre-built clusters that span North America, Europe, and Asia in various configurations. And we provide client code integrations for popular languages. I talked about the Edge platform integration. Cloudflare Workers is available now, and Vercel and Fastly support is coming soon. And a really cool feature of pgEdge Cloud is latency-based routing. And what that means is, without you having to think about it or deal with it in your application code, your application client code is always going to connect to the nearest available node. So if a node happens to go down, traffic will just automatically go to the next nearest node, which is very, very cool. And it just works really great with platforms like Cloudflare Workers. And did we mention that Developer Edition is free? Up to 12 gigabytes of storage across 3 nodes. And if you need more than that, as you may well, as you take applications into production, we do, of course, have paid plans, and we'd love to talk to you about that. But I've spoken for enough here, and with a bit of help from Curtis, I think what we really want to see is the product speaking for itself. And so at this point, I'm going to turn things over to Curtis to actually give you a live demo of pgEdge Cloud Developer Edition. And yes, it really is live. Take it away, Curtis.
Yeah. Hello, everybody, and thank you, Philip. So yeah, we're going to dive right in to see pgEdge Cloud in action. I'll walk you through the agenda real quick. We're going to spin up a global database, start replication on it, and then run some test queries. After that, I'm going to show you the Northwind Traders example application, which is running on Cloudflare Workers. We'll look at how that was built and use it as a reference application when we're talking about low latency routing and ultra high availability Postgres. All right, let me share my screen and we will get started. All right. So this is the pgEdge web application. Once you log in, and this is free sign up. So like Philip was saying, anybody and everybody is encouraged to go ahead and sign up, give this a try, see what you think. Once you log in, you'll see this database dashboard. And we will be prompted to create our first database. We'll go with the default database name for now, and then we just have one choice to make, which is where we're going to place our database nodes. Out of the box, Developer Edition has 3 options built in. So you can choose US and Europe, a global cluster, or a US only cluster. And I think we'll go with US and Europe for now. And to look at where the database nodes are going to be located, you can see that we've got 1 in Oregon, 1 in Northern Virginia, and 1 in Frankfurt, Germany. So that's where our database nodes will be created. We'll opt in to installing this Northwind Traders dataset, which I'll tell you a little bit more about soon. And we'll click Create Database. So pgEdge is now spinning up a Postgres database for us at each of those 3 locations. We set up private networking and logical replication between those locations. We assign unique domain names to each database node and to the cluster itself. And that lets you connect to either the closest node to your client or application or to a specific node of your choice. And I'll give you a quick explanation of node names in the cluster. So we use the names N1, N2, and N3 to refer to the 3 database nodes. So some information you'll see here in the dashboard relates to those nodes. All right, so the database is now up. We have a globally distributed Postgres at our disposal. We can click this one button to start replication on all the tables in the database currently. These 14 tables we have here are from the Northwind Traders dataset that we opted into. So you get an overview of all the tables, and you can see replication is now starting on all that. When that startup finishes, and it looks like it just did, any change to any of those tables will be replicated across the cluster. So, an insert, an update, or a delete on N1 would be replicated to N2 and N3. Similar on all the other nodes, making this a multi-active Postgres setup. I'll talk you through a little bit more of the dashboard in a minute, but you can see briefly that you can see the Postgres users available in the database. You can see instructions on how to connect to the different nodes, and then we see various metrics for the cluster. We won't get into that too far right now. What I'm going to do next is actually show you how to connect to the database, and then we'll confirm that replication is actually working. So give me a moment. I'm going to set up my terminal, and what we're going to do is connect in one terminal window to N1, and then in a second terminal window to N2. Make a change, and we'll see replication flow across the cluster. All right, so I'm going to grab my connection strings here. We are just going to use pSQL, which is a standard Postgres client. And that kind of, can highlight the point that pgEdge is pure Postgres, like Philip mentioned. So all your existing Postgres tooling does work out of the box with pgEdge. In just one moment, I'll switch to my terminal. Okay, I think you should see my terminal window now. I'm going to grab those connection strings from the UI. So I'm going to paste this one in. So now we're connected to the N1 database node. I'm going to grab the other one, connect to the N2 database node. All right, so we've got two connected pSQL clients. If you take a close look at the host name we connected to, the difference. The first one is IAD, which is Northern Virginia. Second one is PDT. That's the airport code for Oregon. So you can tell we're connected to two different locations. And if we peek at the Northwind traders tables, I know we've got a categories table. So select star from categories, we can see there's 8 records in that table already. We'll do the same on the second node. All right, so we can see we've got the same starting point on both nodes in the cluster. And I'm going to grab an insert statement, paste that in here. All right, so we're going to insert what will be a 9th record into the database table called snacks. We'll insert that, confirm that our new record is there. All right, so as expected, it's there on the first node, but now we'll query on N2 and see that same record is also on N2 without us doing anything. So from that, I hope you get the gist that any update to any of these tables is going to automatically be replicated throughout the cluster. And I've got a number of other things to show, but that wraps up this little segment with pSQL. So I'm going to stop sharing, switch back to my browser. All right, so back to the pgEdge web page. I'll show you this in the metrics, which kind of reflects the activity we just did. So the bottom metric we have here, replication output, this indicates how much outgoing traffic, how many outgoing records were sent from each node. And if you remember in the terminal window, we actually wrote to N1. And here you can see that N1 had replication output to the other nodes. So that's just a nice way to see replication activity in the cluster. All right, so that is, the simple form of the operation of this. You saw that it's really quick to spin up a database from scratch, one click to start replication in the cluster, and then you connect to it and interact with it just like you would any other Postgres database, which is pretty awesome. I will show you one or two other things in the UI here, and then we're going to take a closer look at the Northwind Traders application. One other quick thing to show in our user interface is you can actually drill down into each of these tables and see the live data. So you can see on our table viewer, categories table, we've got that 9th record for snacks, which is the one we inserted. So this is just a nice way to browse database contents. And with that, I will pause here and we will go to the Northwind Traders demo application. All right. Yep, I think you're seeing the right thing. So to give you a quick overview of what this is, and just so you know, everybody listening can actually go ahead and navigate to this URL too, if you'd like. It's northwind.pgedge.com. And so this is an app we spun up online to basically highlight the combined usage of Cloudflare workers with a pgEdge globally distributed database. Cloudflare has a serverless compute offering called Cloudflare Workers, which you may have heard of. It's also similar to like AWS Lambda, for example. And it's just a really nice pairing with pgEdge because it is fundamentally globally distributed compute. And so you can then have Cloudflare Workers point to a pgEdge database, and that gets you low latency access worldwide, and it gets you ultra high availability. So in this app, this whole web page is actually served from a Cloudflare worker itself. Here is kind of the really fun web page where if we navigate here to the dashboard, and like I said, you can do this on your side too right now if you want, you can see a map of where people are connecting from and what Cloudflare colo they are connected through, and then what pgEdge database that is querying. So I'll walk you through different aspects of this so we can see it all in action. I believe the way this app is set up is that actually we're showing the latest, the most recent 100 requests from around the world for anybody accessing this app. So on the globe here, you can see we've got a 3-node pgEdge cluster. It happens to be in that same configuration that we spun up earlier with US West, US East, and Europe. And then each blue circle indicates where somebody connected from. The little flame icon is the Cloudflare data center they were routed through. That's where the Cloudflare worker actually ran. And then the yellow icon is where the pgEdge node is. I know this happens to be me. So I'm routed through the Northern Virginia data center to the close pgEdge node. And for that setup, you can see the Cloudflare latency and then the corresponding pgEdge latency. And if we refresh this web page, you get a new latency measurement with each attempt. So you can see that I can interact with the Cloudflare worker with a latency of about 68 milliseconds. And then from that worker to the nearest pgEdge node was only 3 milliseconds. Obviously very quick. So you're going to have nice responsive web apps with this setup. Similarly, you can give this a try and see what the latencies are like in your neck of the woods. If we navigate in this app, you see, this is querying different database tables behind the scenes, suppliers, products, orders. As we navigate, the Cloudflare worker is issuing SQL queries against the pgEdge database. And then if we come back to the dashboard now, you can see some logs we're capturing from all that activity. So you can see the specific queries that were executed and how long they took. And overall, you can see single-digit access times are possible depending on the query. And yeah, give this a try. We think it's a really fun app where you can get the sense of how this all works in practice. So let's talk about latency routing specifically for a minute. With latency-based routing, this is a way with pgEdge generally, we can make sure that any client or application that's connecting to your cluster gets connected to the closest node. And that guarantees they're getting the lowest latency, highest performance. That's enabled on every pgEdge database automatically. And we're using a feature called latency-based routing in DNS specifically. And that means DNS will automatically resolve you to the correct database node. And that means in your client application, you actually don't have to do any work to enable this. It's just for free. And the DNS setup that we enable for you has failover in place, where if one of the nodes goes down, you're automatically routed to one of the other nodes. So that's just a really nice high availability type feature. And then, you know, to talk globally about how other users are, you know, going to interact with this, you know, you can see how big of a difference this is going to make for users connecting to an application in Europe, for example. If we only had that database in the United States, all these users would be connecting overseas and have, you know, connection and query latencies in the 200 plus millisecond range. And when you've got a series of those queries stacked up in a web application, that is going to be very noticeable. Your app is going to be harder to use, and people will leave it. So having this node located here in Europe makes a huge difference for these people, where they can see single digit query times, single digit latency, that is. So this is a big deal, and we're really happy about how easy it is to spin up these clusters and make use of them. All right. So yeah, I hope you all give this a try. You can go to northwind.pgedge.com to load this. And if anybody has hit it in the last few minutes, you might see your location reflected on here. All right, let's see, how's my time going? All right, I've got just one or two other things to show, and then I'll be handing it back to you, Philip. So the source code for this application is available on GitHub. So pgEdge/pgEdge Northwind is our open source GitHub repo for this. You can take a look at how we built this. I'll just call out real quick in here that, like I had mentioned, all your existing Postgres tooling just works with pgEdge. So in the package.json for this Cloudflare worker, for example, we're installing the straight up PG package. That's the one your, you know, TypeScript or JavaScript applications may already be using. Same is true with Go and other languages. You can use your existing libraries. And it is very easy to query this. This setup has an interesting configuration for routing. So each Cloudflare worker can actually handle multiple routes, and that corresponds to different database queries behind the scenes. So that one Cloudflare worker basically sets up a super lightweight web server where you can do a number of different database queries and return different data to the front end. We think that's a pretty handy setup. And then one final thing I will share is, if you want to give this a try yourself, we have this Cloudflare worker template. If you click this button in the GitHub README, it actually kicks you into this workflow where you can connect pgEdge to your Cloudflare account in a really quick way. And this workflow and the README in the GitHub repo walks you straight through it. Should take less than 5 minutes to get a pgEdge plus Cloudflare set up if you want to experiment with this. All right, let's see. And I will just switch back to the app very briefly. Oops. All right. In Developer Edition, you can spin up one database for now. Give this a try. You saw it takes 90 seconds or less, maybe even 30 seconds if you're lucky. And it's we're really looking forward to hearing everybody's feedback on this and learning more about the use cases where you're going to try this out. So thank you for taking a look at this. Back to you, Philip.
Thank you so much, Curtis. Let me just pop the presentation back here. So awesome stuff. And as Curtis said, we're really proud to be putting not just our pgEdge distributed Postgres product out in the market, but now with Developer Edition, making it really super accessible to everyone without having to worry about configuring infrastructure and downloading software and all of that good stuff. So I think, Jacob, we're ready to take some questions. Oh, one thing I will note, which I find kind of interesting. Usually, the marketing and CEO types will come out with some marketing claim like, deploy in 3 minutes or less, and the engineering folks get nervous about that and put caveats on it. But in this case, we said 3 minutes, and Curtis goes with 90 seconds. So kind of a fun little fact there. But let's switch over to some live questions. Oh, I'm teasing
All
the
right.
t-shirt.
All right, awesome presentation and demo. And I can confirm from my end too, that was as close to 3 minutes as humanly possible, and even better, as you said, 90 seconds. So as we move on to the Q&A section, please feel free to ask any questions in the chat now. I know we have some rolling in. We'll get to those first. And I mean, it doesn't get any better than having it answered by Philip and Curtis right from the source. So to start off, we have Lee asked the question, does the tooling that works include nearly all available Postgres extensions?
It is compatible with Postgres extension generally. Out of the box and Developer Edition, we include pgvector, since that's a really common use case right now, as well as a couple of the pgEdge specific extensions. To have full control over that, the pgEdge Enterprise editions would give you complete control over that.
Mm-hmm. Okay. And another question is, Postgres can't logically replicate all DDL operations. Are there DDL or other operations that pgEdge can't replicate as expected?
Right. Yeah, this is a great area to talk about. So behind the scenes, pgEdge has a Postgres extension called Spock that is kind of key to this whole logical replication setup for us. Spock is what replicates both the data in the tables as it's being updated, but it can also help you replicate your DDL statements. DDL statements are the statements where you create or alter tables. So Spock has a replicate DDL function built into it, which if you call that in your SQL, you can actually, distribute that DDL command to all the nodes in the cluster. That's one option. Cloud Developer Edition also helps you set this up. As you might have seen, the start replication action, when that's triggered in Developer Edition, fans out your tables onto all the nodes and replicates them automatically. And then in the very near future, we continue releasing DDL related improvements so that more and more of that will be completely automatic over time, thanks to what we're doing in Spock.
Very interesting. And so right after the demo, Zorian asked, how about backup?
Yeah, so what you get out of the box with Developer Edition today are full nightly backups, which are stored in the cloud, and then you can download them directly. And then, those are like pgdump style backups that you can then take and do what you want with. Obviously, pgdump full backups are only they only work well with relatively small database setups like the ones you'd have in Developer Edition. For pgEdge Enterprise and larger database setups, we have PG Backrest integrated, and so you can do full incremental backups with that.
Mm-hmm. And another question is, what is your cadence for keeping up with major Postgres releases?
Yeah, great question. Because we're pure Postgres, our extensions are easily updated to work with each new Postgres version, and we just have a couple small patches we apply. And so that means we can release a new version of pgEdge to match each new version of Postgres within a week or less of each update. So I know the team's already has Postgres 17 compatibility in the works. So yeah, that's available within days.
Mhm.
In pgEdge Enterprise Edition, you can opt into installing different major versions of Postgres. So we've got 15 and 16 support right now. What you get in Developer Edition is Postgres 16 out of the box.
Okay, great. And another question we have is, what is the transaction isolation level like? With the conflict-free data type, it seems like pgEdge allows a weaker isolation level, and seems like it's a trade-off between high availability and data consistency. Would you share a bit about the decision?
Yeah, Curtis, you want to take? Well, actually, I can take that one as a former old database geek. Great question, and some of you might be aware of the CAP theorem. You have to have a trade-off between consistency and availability, and we have optimized for availability and low latency, which comes along with that, sort of two sides of the same coin. We are an eventually consistent database with conflict resolution and what we call conflict avoidance, which effectively is a form of easy to use conflict-free data types for, in particular, running sums. What we've found in practice working with customers is that a lot of workloads tolerate eventual consistency. If you have a transaction where it does need to be completely consistent across the cluster, talk to us and we can talk about how we can implement that as a synchronous transaction. But particularly with geographically distributed applications, the workloads kind of break down into geographic distributions. So, if you've got customers in Asia Pacific, they're hitting the Asia Pacific node. Likewise, European customers against the Europe node, and North America against the North American node. And it would only be for things like global aggregate tables where you might see a little bit of replication lag, meaning that your data is maybe a second or two behind, depending on what that replication lag happens to be. But that's a little bit about how we think about the trade-off there, and happy to engage on that question in more detail one-on-one for anyone who would like that.
Great. Thank you for the answer, Philip. Another question that we have from Achilles is, what about sequences?
Yeah, I can take a stab at this, and then Philip can elaborate as needed. But yeah, out of the box, so auto incrementing sequences, like you may have in some of your Postgres tables today, are kind of a poor fit for distributed Postgres. And so that's why pgEdge has a Postgres extension called Snowflake sequences. And what this helps you do is migrate those existing sequences in your tables to be compatible with distributed Postgres, and do this in, as easy as possible for you. And what that basically does is it incorporates a node identifier into each sequence number that's generated, and that allows you to generate sequences on all nodes in the cluster with a guarantee that they won't conflict. So this is one easy migration path from existing auto incrementing sequences in your tables to pgEdge and Snowflake sequences. You can also, of course, switch to more like a UUID primary key, and that also works. But Snowflake sequences would be the way to do it with the minimal amount of effort for existing tables with incrementing sequences.
Right. Well, thank you, Curtis. It's really great to see all these great questions rolling in. So Lee asks,
good ones. Covering all the bases.
Right. So Lee asks, how do database upgrades work?
Yeah, and this is one of the great things about logical replication, is it gives you a lot of flexibility, which you don't have with physical replication necessarily. So the idea is you can one by one in a cluster upgrade a node from major version of Postgres to the next major version of Postgres. If you take that node out of replication, do the upgrade, resume replication, and have it catch back up, that's generally how you can approach kind of a rolling update to updating Postgres versions. That can get infinitely complex depending on your setup, but that is the general approach, is that you actually leverage logical replication for this. Take a node out of the replication, do the upgrade, bring it back in. And if you do that for each node in the cluster, then you've updated Postgres.
Yeah, and Curtis, just to add to that, that's part of the managed service that we provide in pgEdge Cloud, right?
Right. Yep, that's right. So it would be out of scope for Developer Edition, but with our Enterprise Edition, where we help you, or where we manage the clusters, we help you with that.
All right, great. And Vladimir asks, what about encryption? What if the data has to stay within the EU?
Yeah, Curtis, you want to take the encryption question, and I'll take the EU data residency?
Yeah. So we, a number of folks on the team have a cloud security background. We're using infrastructure as code behind the scenes to help set all this up in a secure way. There is network encryption between all the nodes on the cluster. It also takes all the traffic over the cloud provider network backbones rather than the public internet. So you've got a couple different layers of network safety there. And then all the data is encrypted at rest. So if the cluster is running in AWS, for example, you've got encryption on your EBS volumes, among other things. And then, yeah, over to you, Philip, for the data residency.
With the question about data residency and what if the data has to stay within the EU, with Developer Edition, by default, everything is being replicated everywhere across the cluster. However, with our pgEdge Cloud Enterprise Edition and our pgEdge Platform product, which is the self-hosted, self-managed, downloadable pgEdge offering, you have the ability to control replication with a much finer grain of control. What that means is you can actually address that data residency problem that you're asking about. So you've got European customers who want to make sure that European resident generated data stays in Europe, doesn't cross the ocean. Replication winds up being a very, very neat architectural solution to this, particularly when you compare it with what a lot of people wind up doing. And I've done this previously at SaaS companies I've run, where you stand up an entire copy of the application stack with its own isolated database, and nothing talks to anything else. So what you do is you selectively say this set of tables, or even you can do it with partitions or row filtering, but this data is global and we want to replicate it across the whole cluster, versus this data here, your customer PII and your customer generated orders and so forth. This has to stay local, and so it will just stay on the European node. So it winds up being architecturally a really neat solution, but at this point, that's not something we can kind of open up access to within Developer Edition. Maybe down the track we might be able to, but for anyone who has those data residency issues, talk to us, because with Enterprise Edition and pgEdge Platform, we've got a really neat solution for you.
Very interesting. And yeah, data residency is definitely a big topic and concern now. Yeah, so as we wrap things up, I want to encourage anyone to ask any final questions. They've been great rolling in thus far. One question that I have is, why is now the best time to release pgEdge Cloud Developer Edition, and how do you foresee people will be using it in the future?
Yeah, so great question. The reason why we founded pgEdge is because there really was no easily accessible open solution for distributed Postgres in the market. And so there's some other distributed databases which are fine products, but they're either not actually fully based on Postgres, or they're not open source. So we know that those things are important to Postgres developers. So that's why we started the company, and that's why now, because nobody had done it. So that's the why now. Sorry, there was another part to the question as well, Jacob.
Yeah, and what's next in the or how do you foresee that people will be using the platform in the future, and any advancements in the platform that you have planned?
Well, obviously we're not going to sit still here, and we've got a great roadmap, which again, one-on-one we can share with folks. But we really see this as the beginning of really a new era in applications, and hopefully that's not too grandiose sounding, but databases have been imprisoned in just one place for too long, and being able to address the problems of latency and high availability is fabulous. But we think that there's going to be a whole new generation of applications that take full advantage of distributed capabilities, and we can't wait to work with builders out there on those new applications without necessarily knowing exactly what direction they're going to take. But we're a fast-moving, agile company and very responsive to customer input. So we're just loving working with our customers on really driving this forward.
Awesome.
Yeah, and we, like you saw, and we all know, Postgres is so extremely popular. And a lot of times when people have to opt out of using Postgres, it was exactly because, there is lack of multi-region support, or they had, other capabilities that we actually can address now with pgEdge Cloud. So, this is giving people the opportunity to use Postgres in more situations than they could before without having to opt for a different type of data store.
Very interesting. Thank you so much for the insight, Philip and Curtis. And as we wrap things up, is there anything else you would like to add about distributed Postgres, the new solution, or any parting thoughts for our attendees?
Well, thanks for the opportunity to close us out here, Jacob. This has been tremendous, and really love the questions. So the one closing thing we want to say is, number one, just go give it a try. It's literally as easy as Curtis showed you, 90 seconds or less. We're not going to argue about 90 seconds versus 3 minutes. And get started at that URL that's right there. And the first 500 people who sign up are going to receive a free T-shirt. Unfortunately, we can only do this in the US. As you can see, it's an extremely cool T-shirt, and actually, we can't wait to get our own copy of that.
Great. We actually had another question roll in from Justine saying, I'm already running an app using 3 self-hosted nodes. My next step might be to test adding 2 more nodes. I was wondering what could potentially become a problem or not with too many nodes.
Yeah, that's great to hear you're already up and running with it. Go for it. I know we've done 5 or more nodes in testing. In fact, quite a bit more than that. But what we recommend right now is 5 or fewer, is kind of the recommended and most common supported configurations. And it really depends a lot on your specific situation to go deeper than that. So we're happy to chat with you more about it. And actually, I'll mention here that we have a Discord channel, and there's a link to the Discord community in the app. So you can kind of connect with us there, and we can chat deeper on it if you want.
All right, great. Looks like that's all the questions that we had come in. Thank you for this presentation again. Again, that was Philip Merrick, co-founder and CEO at pgEdge, and Curtis Mizey, Vice President of Product at pgEdge. And for everyone attending, be sure to check out the link on the slide to learn more. I'd also like to thank pgEdge for sponsoring today's webinar, as well as the attendees for joining us. Hope everyone has a great rest of the day.
Thanks so much, Jacob. Thanks, everyone.
Thank you all.
Thank you. Take care.